Hello, how you guys doing today? Today we're going to learn about quadratics and how to factor to solve them. Alright, so essential understanding. A quadratic function is a type of nonlinear function that models certain situations where the rate of change is not constant. The graph of a quadratic function is a symmetric curve with the highest or lowest point corresponding to a maximum or minimum value. Alright, that sounds like a bunch of mumbo jumbo you guys probably don't understand, but you will by the end of this video. Alright, but that's what we're learning today. So the first thing we need to know is what standard form is. Standard form of a quadratic is ax squared plus bx plus c, and it equals to 0. All right, a and b and c, those just are letters that represent numbers. All right, it's always probably going to have an x. Sometimes I might mix it up and throw a different letter in there, but usually it's an x. So this just means some number being multiplied by x squared, some number being multiplied by x, and then adding some number, and it always equals 0. All right, some things you need to know. Solutions, what they can ask for is they can ask for solutions or answers or roots or zeros. And we're going to learn how to do those. All right, so the first thing we need to know is what a quadratic function is. And a quadratic function is a U-shaped curve called a parabola. If you look down here, this is a parabola. It's just a U-shaped curve. All right, parabolas are symmetric. So if I folded this over, it'll be equal on both sides. Right? Parabolas have a highest or a lowest point called a vertex. If a parabola opens downwards, like this one here on the A, then the vertex is the maximum point. So what's the maximum point of this parabola or this curve? It's the highest point it can be. The highest point that this can be is right there. And what is that? Well, that point is 0, 3. Right? If a parabola opens up, the vertex is the minimum point. Like this one opens up. It has arrows pointing up. It's opening upwards. So this is a minimum point. The minimum this one could be is right here, right? Because that's where the curve stops and then goes back up again. So what point is that? Well, that is at 1, -1. Okay? On a graph, if they ask for the roots or the zeros or the answers or the solutions to a quadratic and they give you a graph, it's really easy to find the solutions. It's wherever it crosses the x-axis or where the y equals 0. So that when the y equals 0, remember it says equals 0, then that means it crosses the x-axis. So that means we can look where on the x-axis, and those would be our answers. So the answer to this one would be what's about -3.5 and +3.5. And if I was going to look for the x-axis on this one, I can see it's here and here. So my solutions to this one would be 0 and 2. So wherever they cross the x-axis is our 0 or our root or our answer or our solution to our quadratic function. Alright, so I've been talking about zeros, so let's go further into depth with that. So a long time ago, when you start learning about multiplication, you learned this thing called the zero product property. And you may not know that by that exact term, but you know it without knowing it, really. It's anything times anything that gives you 0. That means one of the factors, one of the multiplying things, has to be 0. So if a times b equals 0, then that means either a equals 0 or b equals 0, or they both could be equal to 0. Right? Because anything times 0 is 0. All right? So we can use that zero product property to solve these types of equations. All right? So since I know that one of these has to be 0, I can set them equal to 0 and solve for x. So in this example, I have x plus 1 times x plus 6 equals 0. So what I do is I separate these two out, like this x plus 1, and I'm going to set it equal to 0. And I can also set this x plus 6 and make that equal to 0. And then what I do is I solve these to find my answers. I want to solve for x. So this is x plus 1. I'm going to do -1 to get rid of that and leave me with x. And 0 minus 1 is -1. And I can do the same thing to this other binomial that I pulled out. X plus 6 equals 0. So I can do -6 to get rid of that 6 and leave me with x. And I can do the same thing to the other side of the equal sign. 0 minus 6 is -6. So I know my answers are x equals -1 or x equals -6. All right, let's go on to number 3. Let's try that one. So I have these two binomials and they're equal to 0. So I know that I can set each one to 0 because of my zero product property rule. So 3x plus 4 is my first one. I'm going to set that equal to 0. How would I solve this? Well, I want to get that x by itself. So I see that's a plus 4. So I'm going to do -4 to get rid of that. And do the same thing on the other side. And that would leave me with 3x equals -4. And then I would divide by 3, right, to cancel that 3 out and leave me with x. And then I want to do the same thing to the other side. -4 divided by 3 is -4 thirds. Now I have to set this other binomial to 0. So I have 2x minus 8. That could also equal 0 because of my zero product property rule. And now I can solve for x. So I would get rid of that -8 or that -8 by doing +8. And I do the same thing to the other side. 0 plus 8 is 8. And on my left side, I'm left with 2x. And then I would divide by 2, right? To leave me with x on my left side. And I would divide by 2 on the other side to keep it balanced. So 8 divided by 2 is 4. So my answers for this quadratic, it could be x equals -4 thirds or x equals 4. All right, let's try one more that you might see. Number 4 here. I see there's a 5 on the outside. And then I have the two binomials. How would I solve that? Well, I know I can get rid of that 5 when the number's on the outside of parentheses. I can get rid of it by doing the distributive property, right? So I can times that by the things on the inside of the parentheses next to it. 5 times m would give me 5m, and then 5 times 4 would give me 20. And now I know that this m plus 4 could equal to 0, so I could set all of that equal to 0. And then now I can solve for m. So I would do -20 here to get rid of this rate. Do the same thing to the other side. That leaves me 5m on my left side. And 0 minus 20 is -20. And then I want to solve for m, so I could do divided by 5 to leave me with just m. And do the same thing to my other side. -20 divided by 5 is -4. And I can do the same thing to this m minus 4, because that could equal 0. So m minus 4 equals 0. And I want to solve for m, so I would do +4 to get rid of this, right? And leave me with m. And I can do the same thing to the other side. 0 plus 4 is 4. So the answer to this quadratic, m could equal either -4 or m could equal 4. That would be my answer. So all you do is you take the binomials and you split them apart, and you set them equal to 0, and then you solve for x, or in this case down here, m. You solve for the variable that's attached with it. All right, what do I do if they give me something that looks like this, though? It says x squared plus 2x minus 15 equals 0. Those don't look like the other ones we did where they were binomials, right? So what can I do here? Well, the last couple weeks we've been learning on how to factor something that looks like this, right? So what we can do is we can rewrite this x squared plus 2x minus 15. We can rewrite that by using its factors. All right? And since those two binomials are what we get when we factor, then we know that we can set that equal to 0. Right? And if they're equal to 0, that means that if we graph them, we would see them at the x-axis. Just like how I showed you on that first part. When I was showing you the minimum and maximum of those parabolas. All right, so if I was going to factor this, remember I make like my little x, and then I multiply this first term by this last term. So this is really a 1. 1 times -15 is -15. And I take this middle term, that 2, and put it at the bottom. And I say, what times what gives me -15, but adds to give me 2? Well, what times what gives me -15? Well, no, 15 and 1, but that won't add to give me 2. I know one of these has to be negative, because this is a negative here. And it has to add to give me a positive, so I know the bigger number has to be positive. Well, I know 5, right? 15 can be divided by 5, and 5 and negative 3 will give me negative 15, and if I add these two, it will give me 2. So that works. So now I can continue to factor it. And I can factor it by either doing the grouping method we learned, or I can do the box method. Doesn't matter. You'll get the same answer. Just whatever one you feel more comfortable with. So I'm going to do the grouping method. X squared plus 5x, I got that 5 from right there, minus 3x, I got that negative 3 or that minus 3 from right there, minus 15. And then I can continue to factor this. Remember, I can do this because 5x minus 3x will give me this original 2x. So this equation and this equation are both equal. All right, so when I factor by grouping, I group my first two terms together, right? And I say, what do these things have in common? Well, they both have an x. All right, so I took out an x. So this was x squared. I took out an x. That leaves me with an x. This was 5x. I took out the x. So what's left is a 5. Right? And now I can do the same thing to this next set of two terms. I have negative 3x and negative 15. What do they have in common? Well, I can see that they both have a negative, and they can both be divided by 3. So what's left over? Negative 3x divided by negative 3 is x. Negative 15 divided by negative 3 is a positive 5. And I got the two things in the parentheses the same. So that works. So I have x plus 5. And what's left over, remember, is my other binomial, this x and this minus 3. X minus 3. And all this was equal to 0. So since I know that's equal to 0, I can set each of these binomials now to equal to 0. So x plus 5 equals 0, and x minus 3 equals 0. So now I can solve for x. So if I want to get x alone, I would do minus 5, right? And that would leave me with x equals 0 minus 5 is negative 5. And on this side, I would do plus 3 to get x by itself, right? Cross that off over there. 0 plus 3 is 3. So the answers to this quadratic, or the roots, or the solutions, or the zeros, is x can either equal negative 5 or x can equal 3. All right, and on a graph, what this would look like, I can type this in as x, my original equation, x squared plus 2x minus 15, right, equals 0. And then where does it cross my x-axis? Well, I see it crosses at negative 5. My x value is at negative 5, right? See that? That's one of our answers we got. And what's my other answer? 3. X equals 3. And if you look, it gives us this parabola, this U-shaped curve here, as an answer. That's a quadratic. And in our solutions, what we just solved for is where it crosses the x-axis. So solutions or roots are always where it crosses the x-axis. So Desmos is a very useful tool to check your work. All right, so let's look more at some graphs. Look at these graphs here. So if you graph something and you're looking for solutions or roots or zeros, they're the x-intercepts, right? So if you look at this one, it crosses here at negative 5 and it crosses here at negative 1. So this one has two solutions. The answers are x could be negative 5 or x could be negative 1. In this example, it only hits the x-axis once. So this is one solution. The only possible way it could be, answer it could be for x would be x equals 4. All right? If you look at this one, it never crosses that x-axis because it stops here and it's pointing up. Both of these are going up that way, right? So it's never going to cross that x, so this is no solutions whenever you get something like that. All right, continue on, do the math homework. If you have any questions, please feel free to ask in either the classroom or during my office hours. Office hours, remember, are Wednesdays or Fridays. Wednesdays, I'm in there from 11 to 1. Fridays, I'm in there from 1 to 3. It's that same Blackboard Collaborate site. All right, you can also always email me. My email is wsthurston@fcps.edu. All right, I'll see you in class. Have a good one.